to our today's lesson, and today we want to look at something in mathematics, and what I want to discuss today is calculus. And I'm your tutor, Mr. Ngatia, calculus. So calculus is a topic that gets covered, for example, in the Kenyan system at what we call the last stage before a student actually sits for the examination. So in this case, when you talk about calculus, it actually quite again gets covered in other curriculum, and as far as our education is concerned, it is even taught at the university level, at the college level, and not only at the O level. So it's actually a topic of so much interest, and it actually quite covered some areas. I'll be able to discuss some areas that are very, very crucial in as far as this topic is concerned. So when you talk about calculus, you have to actually mention the following. Number one, you have to talk about differentiation, and number two, you have to talk about integration. So integration and differentiation. So integration and differentiation. So integration and differentiation. So you have to mention differentiation, you have to mention integration. So today I may only discuss differentiation, such that in our next video we shall be able to look at what integration entails. So I'm going to look at differentiation. Good. Now under differentiation, there are things you're supposed to know how to do them. Number one, you have to know how to get what you call dy dx. So that means you have to get what you call the gradient function of a curve. Gradient function of a curve. The gradient function of a curve. You can just imagine having this as your Cartesian plane. So you have what you call the y-axis and the x-axis. In this case, you must have a curve having such a shape to some extent. Then you can have actually a line getting drawn going like that. Then someone can be able to actually have something getting drawn like this. Then you can as well drop a line coming to the base. In that case, you can have as well something going like this. Good. So in this case, I have at this point y plus change in y. Good. Then you may have here another y here. Then you may have actually now the change in y. Good. You may have here xy, so a point A that has xy, and in that case you might have something of this sort like that. So you can say change in x. Good. That is dx. Now that's just a simple sketch of how a curve can look like, and in that case we may not so much have what we say discussing of this, and we may just go straight away to what we can be able to actually do for today. And in this case, that means you're supposed to actually ask ourselves, how do I get, or how do we eventually end up getting the right answer as far as getting the dy dx is concerned, or the gradient function? So for example, if I have been given such a question here, look at this. I've been told there's a question here. The equation of a curve is y is equals to 3x squared minus 4x plus 1. The first part says find the gradient function of the curve and its value when x is 2. Find the gradient function of the curve and its value when x is 2. So the question reads 3x squared. Of course, y is equals to 3x squared minus 4x plus 1. So how do I get the gradient function of such a curve? So gradient function, or you can so be able to say dy dx, or change in y over change in x. How do I get this? You're gonna come and pick this curve and be able to write it here. 3x squared minus 4x plus 1. Now with differentiating, what you're supposed to do is you have to actually differentiate this curve for you to get the dy, the dx, or the gradient function of this curve. Good. So for me to get the gradient function of this curve, to get the dy dx of this curve, or to get the gradient of this curve, what do? I'm supposed to actually come here and be able to say gradient function or dy dx is equals to 3x squared minus 4x plus 1. So in this case, I'm going to actually be able to do what? Look at this number here. This is the power. This power gets reduced by 1. This power gets reduced by 1. Then this number gets multiplied by the coefficient of x. Look at this. So I'm going to say 3 times 2. Okay? Then I say x. Then I'll say 2 minus 1. Look at that. So the power was 2. I multiplied by the coefficient of x. Then the power was 2. I reduced the power by 1. You get the point? So that means when you are differentiating to get the dy dx, when you are differentiating to get the dy dx or to get the gradient function, just pick the power, multiply by the coefficient of x, then reduce the power by 1. Pick the power, multiply by the coefficient of x, then reduce the power by 1. Okay, so I'll come here again and say minus, then I have 4x, that's the same as 4x raised to 1. So I'm going again to pick the power, multiply by the coefficient of what? X, so 4 times 1. Then I'll write my x, then the power is 1. I'll reduce the power by 1. Look at that. Then I'll come here and say plus 1, so plus 1. Look at that. I assume this one has x, and if it has x, it must be x raised to 0, because there's no x there, so I'll just actually assume there's an x, then I raise that x to 0. Now, in other words, I'm going to say 3 times 2, that gives me 6, then x, 2 minus 1 is just x, which is just x raised to 1. Then minus, I'll come here and say 4 times 1, that is 4, then 1 minus 1 is 0. You see, so I'll actually end up having x raised to 0. Good. Then plus, I'll come here. The power, I actually say there was no x here, so I introduced my x, then raised this x to 0. So I'll say 1 times this. So it's actually saying 1 times 0, then raised to x. And of course, this x has to have 0 minus 0. So I'm going to have 6x minus anything raised to 0 is 1 in mathematics. So that is actually to say x raised to 0 is 1. So 4 times 1, I just get 4. Then plus 1 times 0 is 0. X raised to 0 minus 0, 0 minus 0 is 0. So x raised to 0, that is actually just the same as saying 0. So it's just like saying 0. So our end GF or dy dx should be 6x minus 4. Good. 6x minus 4. Pick the power, multiply by the coefficient of x. That is it. Pick the power, deduct 1. Reduce the power by 1. Great. 3 times 2, 6. Then x raised to 2 minus 1, that is actually x raised to 1. That is done. Come here, pick the power, multiply by the coefficient of x. 4 times 1. 4 times 1. Then x. Pick the power, reduce by 1. 1 minus 1. So 4 times 1, that is 4. Then x raised to 1 minus 1, that is x raised to 0. So plus, come here, 1 times 0. You see, I said there was no x here, so I introduced my artificial x. So this x here, you see, has to get raised to 0 because it was not there, so there was nothing like x there. So I take this 0, multiply by this 1. Actually get 1 times 0. Then I get 1 times 0 raised to, then I'll come here and say x raised to 0 minus 0. So x 0 minus 0 is 0. So I have 1 times 0, that is 0. So that goes like that. So 6x minus 4 plus 0. So 6x minus 4. So when you get a number, when you're differentiating to get the GF or the dy dx, then you get a number that has no letter like x. Just drop that. It does not mean. You see. Just drop it. Okay. So that is our actually gradient function or dy dx. Now, the next part